According to NFPA 101, Life Safety Code, battery-backed emergency and exit lights are required in all occupancies, including banks. The purpose of these lights is to provide illumination in the event of a power outage to facilitate safe evacuation. Therefore, you cannot omit battery-backed up emergency and exit lights. NFPA 110 Emergency and Standby Power Systems requires a dedicated transfer switch for life safety systems in hospitals, nursing homes, and other healthcare facilities. Banks are not typically considered healthcare facilities, so a dedicated transfer switch for life safety is not explicitly required. However, it is good practice to provide a separate transfer switch for critical systems to ensure their uninterrupted operation during a power outage. It is recommended to install a central monitoring system to monitor the generator and other critical equipment, including UPS systems. Conduct regular testing and maintenance of the generator, transfer switches, and UPS systems to ensure reliability. Consider providing redundant UPS systems or additional backup power sources for critical servers and equipment to minimize downtime. It is also important to consult with a licensed electrician and local building officials to ensure compliance with all applicable codes and regulations. When considering emergency lighting for a bank operations center, you need to adhere to NFPA 101. This standard dictates that all occupancies, including banks, must have battery-backed emergency and exit lights. These lights are essential for providing illumination during a power outage, enabling safe evacuation of personnel. Omitting these lights is non-compliant with safety standards. Although NFPA 110 concerning emergency and standby power systems mandates a dedicated transfer switch for life safety systems in specific facilities like hospitals and nursing homes, it doesn't explicitly extend this requirement to banks. Banks are generally not categorized as healthcare facilities under this code. However, implementing a separate transfer switch for critical systems within a bank is a prudent measure. It ensures that these systems maintain uninterrupted operation when the primary power source fails. This practice enhances the overall resilience of the bank's operations. For enhancing system reliability, consider the following measures. Firstly, install a comprehensive central monitoring system to oversee the generator and other vital equipment, including the uninterruptible power supply (UPS) systems. Secondly, establish a routine schedule for testing and maintaining the generator, transfer switches, and UPS systems. This will ensure they operate reliably when needed. Thirdly, explore the possibility of using redundant UPS systems or adding extra backup power sources for critical servers and equipment. This minimizes potential downtime and bolsters operational stability. Lastly, consult with both a licensed electrician and local building officials to make sure that all installations and systems comply with the relevant codes and regulations. This step is vital for upholding safety and adhering to legal standards. Emergency lighting is a critical component of any building safety plan, especially in a bank operations center where numerous personnel and critical systems rely on a stable power supply. The primary purpose of emergency lighting is to provide sufficient illumination to allow occupants to safely evacuate the building during a power outage or other emergency situation. These systems are designed to activate automatically when the normal power supply fails, ensuring that exit routes, stairwells, and other critical areas remain lit. The requirements for emergency lighting are typically outlined in building codes and safety standards such as NFPA 101, Life Safety Code. These codes specify the minimum illumination levels, placement of emergency lights, and duration of battery backup required for different types of occupancies. In the context of a bank operations center, emergency lighting is essential for ensuring the safety of employees and visitors in the event of a power failure. The presence of numerous computers and electronic equipment in such facilities can make evacuation more challenging, as people may be disoriented or have difficulty navigating through darkened spaces. Battery-backed emergency lights provide a reliable source of illumination to guide individuals to safety, reducing the risk of accidents or injuries during an emergency. Transfer switches play a crucial role in ensuring the continuous operation of critical systems during a power outage. These devices automatically switch the power supply from the normal source to an emergency backup source, such as a generator, when the normal power fails. There are two main types of transfer switches: automatic transfer switches (ATS) and manual transfer switches (MTS). Automatic transfer switches automatically detect a power outage and switch to the backup power source without any manual intervention. These switches are commonly used in applications where uninterrupted power is essential, such as hospitals, data centers, and bank operations centers. Manual transfer switches, on the other hand, require manual operation to switch between the normal and backup power sources. These switches are typically used in less critical applications where a brief interruption in power is acceptable. The selection of a transfer switch depends on the specific requirements of the facility and the criticality of the systems being supported. For bank operations centers, automatic transfer switches are generally preferred due to their ability to provide seamless power transfer during an outage. This ensures that critical systems such as servers, security systems, and communication equipment continue to operate without interruption. In addition to emergency lighting and transfer switches, uninterruptible power supply (UPS) systems are another important component of a comprehensive backup power solution for bank operations centers. UPS systems provide a temporary source of power to critical equipment during a power outage, allowing systems to continue operating until the generator starts or the normal power is restored. UPS systems typically consist of batteries, inverters, and control circuitry that work together to provide a clean and stable power supply to connected equipment. When the normal power fails, the UPS system automatically switches to battery power, providing seamless backup power to critical systems. UPS systems are available in a variety of sizes and configurations to meet the specific needs of different applications. For bank operations centers, it is common to use a combination of UPS systems and generators to provide a layered approach to backup power. The UPS systems provide immediate backup power to critical equipment, while the generator provides a longer-term source of power to keep the facility operational during an extended outage. Regular testing and maintenance of emergency lighting, transfer switches, and UPS systems are essential for ensuring their reliability and proper operation. These systems should be inspected and tested periodically to identify any potential problems and ensure that they are functioning according to specifications. Battery backup systems should be tested regularly to verify their capacity and ability to provide power for the required duration. Transfer switches should be inspected to ensure that they are operating smoothly and switching properly between power sources. Generators should be tested under load to verify their ability to provide sufficient power to support critical systems. In addition to regular testing and maintenance, it is important to keep accurate records of all inspections, tests, and repairs. These records can be used to track the performance of the systems over time and identify any trends or patterns that may indicate potential problems. By following a comprehensive testing and maintenance program, bank operations centers can ensure that their emergency lighting, transfer switches, and UPS systems are always ready to provide reliable backup power when needed. Consulting with a licensed electrician and local building officials is essential for ensuring compliance with all applicable codes and regulations related to emergency lighting, transfer switches, and backup power systems. Building codes and safety standards vary depending on the location and type of occupancy, so it is important to consult with local authorities to determine the specific requirements for your facility. A licensed electrician can provide valuable guidance on the selection, installation, and maintenance of these systems, ensuring that they are installed correctly and meet all applicable codes and regulations. Building officials can provide information on local building codes and permitting requirements, as well as conduct inspections to verify compliance with these codes. By working closely with a licensed electrician and local building officials, bank operations centers can ensure that their emergency lighting, transfer switches, and backup power systems are safe, reliable, and compliant with all applicable regulations. When evaluating transfer switch options, consider the following factors. Firstly, the current rating of the switch must be adequate to handle the load of the connected equipment. Secondly, the voltage rating of the switch must match the voltage of the power system. Thirdly, The transfer time of the switch should be as short as possible to minimize interruption of power to critical systems. Fourthly, the switch should be designed for reliable operation and long service life. Fifthly, the switch should be listed by a recognized testing laboratory such as Underwriters Laboratories, all to ensure that it meets applicable safety standards. Emergency lighting systems must meet minimum illumination levels as specified in building codes and safety standards. These levels are typically measured in foot candles or lux and vary depending on the location and type of occupancy. Exit signs must be clearly visible and illuminated at all times, even during a power outage. Emergency lights must be positioned to provide adequate illumination along exit routes, stairwells, and other critical areas. The battery backup system must be capable of providing power for a minimum duration, typically 90 minutes or more, as specified in building codes. UPS systems should be sized to provide sufficient power and runtime to support critical equipment during a power outage. The capacity of the UPS system should be based on the total power consumption of the connected equipment and the desired runtime. UPS systems should be equipped with automatic shutdown capabilities to prevent data loss or damage to equipment in the event of a prolonged power outage. In addition to the specific requirements for emergency lighting, transfer switches, and UPS systems, it is important to consider the overall design and layout of the electrical system in the bank operations center. The electrical system should be designed to provide reliable power to all critical equipment and systems, with adequate redundancy and backup power sources to minimize the risk of downtime. The electrical system should be properly grounded to protect against electrical shock and equipment damage. The electrical system should be regularly inspected and maintained to ensure that it is operating safely and efficiently. By taking a comprehensive approach to electrical system design and maintenance, bank operations centers can minimize the risk of power outages and ensure the continuous operation of critical systems. Understanding the nuances of backup power systems and adhering to relevant codes and standards are paramount for ensuring the safety and operational continuity of a bank operations center. By carefully considering the factors outlined and consulting with qualified professionals, one can implement a robust and reliable backup power solution that meets the specific needs of the facility. The selection of a generator should be based on the total power requirements of the facility, including both critical and non-critical loads. The generator should be sized to provide sufficient power to support all essential equipment and systems during a power outage. The generator should be equipped with an automatic transfer switch to automatically switch the power supply from the normal source to the generator when the normal power fails. The generator should be regularly maintained and tested to ensure that it is operating reliably. The location of the generator should be carefully considered to minimize noise and environmental impact. The installation of the generator should comply with all applicable codes and regulations. It is essential to have a comprehensive understanding of NFPA 101 Life Safety Code and NFPA 110 Emergency and Standby Power Systems to ensure compliance with all applicable requirements. These codes provide detailed guidance on the design, installation, and maintenance of emergency lighting, transfer switches, and backup power systems. It is recommended to consult with a qualified electrical engineer or contractor who is familiar with these codes to ensure that the facility meets all applicable requirements. Proper planning and preparation are essential for ensuring a safe and successful response to a power outage. A comprehensive emergency plan should be developed that outlines the procedures for responding to a power outage, including evacuation procedures, communication protocols, and backup power system activation. Employees should be trained on the emergency plan and their roles and responsibilities in the event of a power outage. Regular drills and exercises should be conducted to test the effectiveness of the emergency plan and identify any areas for improvement. By taking a proactive approach to emergency preparedness, bank operations centers can minimize the impact of power outages and ensure the safety of employees and visitors. The choice of battery technology for emergency lighting and UPS systems is an important consideration. Several types of batteries are commonly used in these applications, including lead-acid batteries, nickel-cadmium batteries, and lithium-ion batteries. Lead-acid batteries are the most common type of battery used in emergency lighting and UPS systems due to their relatively low cost and high reliability. However, lead-acid batteries have a limited lifespan and require regular maintenance to ensure optimal performance. Nickel-cadmium batteries are more expensive than lead-acid batteries, but they offer a longer lifespan and require less maintenance. Lithium-ion batteries are the newest type of battery used in emergency lighting and UPS systems. Lithium-ion batteries offer a long lifespan, low maintenance requirements, and high energy density. However, lithium-ion batteries are more expensive than lead-acid and nickel-cadmium batteries. The choice of battery technology depends on the specific requirements of the application, including cost, performance, and maintenance considerations. The placement of emergency lights should be carefully considered to provide adequate illumination along exit routes and in other critical areas. Emergency lights should be positioned to minimize glare and shadows. Emergency lights should be mounted at a height that is easily visible and accessible. Emergency lights should be protected from damage and vandalism. The wiring for emergency lights should be separate from the normal lighting circuits to ensure that they continue to operate during a power outage. The use of a central monitoring system can greatly enhance the reliability and performance of emergency lighting, transfer switches, and UPS systems. A central monitoring system can provide real-time monitoring of system status, including battery voltage, load current, and generator performance. A central monitoring system can automatically alert personnel to any potential problems or failures. A central monitoring system can provide historical data for analysis and troubleshooting. A central monitoring system can be integrated with other building management systems to provide a comprehensive view of facility operations. The importance of redundancy in backup power systems cannot be overstated. Redundancy refers to the duplication of critical components or systems to ensure that they continue to operate in the event of a failure. Redundancy can be achieved through the use of multiple generators, transfer switches, and UPS systems. Redundancy can also be achieved through the use of diverse power sources such as utility power, generators, and solar power. The level of redundancy required depends on the criticality of the systems being supported and the acceptable level of risk. A well-designed and implemented backup power system with adequate redundancy can provide a high level of assurance that critical systems will continue to operate during a power outage. In summary, ensuring the safety and operational resilience of a bank operations center requires a multifaceted approach to backup power. This includes adhering to NFPA standards, implementing robust emergency lighting, utilizing reliable transfer switches, deploying UPS systems, and conducting regular maintenance. By carefully considering these factors and consulting with qualified professionals, bank operations centers can create a safe and secure environment for their employees and customers.